So now in today's lecture we are going to discuss the electric field due to continuous charge distribution, right? So you may write electric field due to continuous charge distribution, right? Continuous charge distribution, right? The electric field due to the point charge we have seen, it is kq upon r square. I'm taking first illustration. Suppose this is the rod and here the rod of length L, right? And the total charge is q over there, and you have to find the electric field at this point P at distance a from this rod. All right, so what you have to do, you will assume to find the electric field at this point. I cannot write the electric field directly due to this rod, but if I assume an elemental portion of the width dx, and this is the charge dq, right? This is charge what? So dq, and this is the point P, right? This is the distance x plus a. Due to this elemental charge, the elemental electric field is dE. I am going to write the dE is what? K dq upon x plus a ka whole square. Is it clear or not? So to find the net electric field, what you have to do? You have to integrate k dq upon x plus a ka whole square, right? This is k, the dq upon x plus a ka whole square. Is it clear or not? So what is the dq? dq is the small elemental charge in this small portion. So how would you write the dq value? With the help of the unitary method. How to write? If this is the total length L, in the total length L, the charge q is distributed. Therefore, in 1 meter, the charge is q by L. So therefore, in dx meter, the charge is distributed over q by L into dx, and therefore this the dq is equal to q upon L into dx. This is the value of the dq. So I am putting the value of the dq over here. In place of dq, I can write q by L into dx. So if you simplify this, q by L, this is dx upon x plus a whole square, right? Copy this first. Okay, now what is the integration limit? Listen, these charge are starting from x is equal to 0. Here you have to find the electric field due to this charge, 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 due to this charge. So you have to integrate the value from x is equal to 0 to x is equal to L. If you integrate this, you will get the answer, right? Listen, one thing, how to integrate. If you know 1 upon x square, integration is nothing but x ki power minus 2 dx. So the formula x ki power n plus 1 upon n plus 1, you will apply minus 1 upon minus 1 is equal to minus 1 upon x. In the same way, if you consider this the 1 upon x a whole square dx, right, its integration is minus 1 upon x plus a. All right, so here I am writing the integration kq upon L minus 1 upon x upon a from 0 to L. All right, so put the upper limit and minus limit, right? This is the electric field kq upon L, put the upper limit L plus a minus 0 plus a. All right, this is kq upon L minus L plus a plus 1 upon a is equal to kq upon L, right? The LCM is a upon L plus a minus a L plus a. So this is kq upon L, L upon a L plus a, right? This is kq upon a L plus a, right? So this is the electric field at this point due to this rod, right? Copy this. Okay, now the second point is the electric field. Due to the electric field, you have to find due to finite line charge distribution. Line charge distribution. What is that? Finite line charge distribution means, suppose this is the line from A to B, right? And this is the charge whose linear charge density is lambda coulomb per meter. And this is the point P at distance D, where you have to find the electric field such that the point A makes the angle theta 1 and the points B make the angle theta 2. So you have to find the electric field at distance perpendicular distance D, right, from the line charge whose linear charge density is lambda coulomb per meter. So listen one thing. At this point, the electric field will be assumed to be the two direction. This is the x component, this is the y component. If you assume this is the x direction, this is the y direction, it is assumed to be the x, it is assumed to be y. Is it clear or not? So separately the x component, the y component you have to find, right? Then you can find the net electric field, right, at this point P. Is it clear? Right, first copy this, then I will calculate. So how to solve this question? I'm solving this side, right? This is the line charge, right? The linear charge density is uniform lambda coulomb per meter. This is the point A, this is the point B, right? So to find the electric field, what you will assume at distance x, right? At distance x, you assume the portion of the dx. The charge is dq over there, right? So because of dq charge, right, because of this dq charge, the electric field is dE over here. Assume this angle is to be theta. Is it clear? So its component will be the two component, the Ex and this is the Ey. So what is the Ex? You will say dE cos theta, and this component is nothing but dE sin theta. Is it clear or not, you tell? Fine. And if this distance is d, this distance is r. So what is the r? The r value you may write, this is the d square plus x square. Therefore this elemental electric field may write k dq upon r square. What is the value of r? You tell. The r square is nothing but d square plus x square into dq, right? If the linear charge density is lambda coulomb per meter, therefore the dq may be written as lambda into dx. I think you understand this. dq is equal to what? Lambda dq. So dE is what? K lambda into dx upon d square plus x square is the value of this elemental electric field. Is it clear or not? So therefore if you want to write the Ex, so the Ex is what? The Ex is, wait for 1 minute, this component, listen, this component is d cos theta and this component is dE sin theta. Is it clear or not? So if you want to find the electric field in x direction, what you have to do? You have to integrate the dE cos theta. And if you want to find the dy, the y component is nothing but integration of dE sin theta. Separately you will integrate and you will get the dEx and the Ey. So this side I am try to integrate this. So first I will integrate the Ex is equal to dE cos theta. The d is what? The dE is k lambda dx upon d square plus x square into cos theta. Listen one thing, when you will try to integrate this, inside the integration the x and the theta, two variables are there. So you have to convert this x in terms of theta with the help of this triangle, and this is the tan theta. Tan theta is nothing but perpendicular upon base, that is x upon d. Implies that x is equal to what? Say d tan theta. If you differentiate, dx is equal to d sec square theta d theta. Is it clear or not? So this is the dx representation in terms of d theta. So the k lambda I am taking common in denominator. This is the d square plus x square. So what is the value of x? X is nothing but d square tan square theta. In place of dx, I am going to write d sec square theta d theta, and this is the cos theta. I think you are getting each and everything. The k lambda is out. The value of the dx is this. In place of x, d tan theta and cos theta as it is. If you simplify this, the d in the denominator it is d, in the numerator it is d sec square theta plus 1 plus tan square theta into d theta into cos theta. 1 plus tan square theta is equal to sec square theta, it will cancel out. So therefore, this is k lambda upon d. Inside the integration, it is cos theta into d theta, and you have to integrate this. From where to where? These elements are starting from, right? The theta the element start from here, and it is going to this side. These are the element, this the element, this the element, right? So theta start from here 0 to theta 2, because this total angle was theta 2. 0 to theta 2 it was, but it is in this direction. So this angle is what, theta 1, and this angle is theta 2. So you have to integrate minus theta 1 to theta 2. Is it clear or not? So what is the integration of the cos theta? Say sin theta. You will put minus theta 1 to theta 2. Put the upper limit k lambda upon sin theta 2 minus the lower limit sin minus theta 1. Is it clear? Minus sin theta is nothing but minus sin theta 1. So it becomes minus minus plus k lambda upon d sin theta 2 plus sin theta 1. Right. So you may write the x direction electric field is k lambda upon d sin theta 1 plus sin theta 2. Is it clear or not, you tell? So this is the electric field in x direction. You will remember k lambda upon d sin theta 1 plus sin theta 2. Is it clear? I am again repeating the limit. Right. The limit is like this. This is the theta 2. This is the theta 1. You will assume this is the reference line. The angle is 0. Above this, theta 2. Below this, minus theta 1. So therefore, minus theta 1 to theta 2 you have to integrate, and you will get the correct answer. Right? Copy this. Okay, now I'm going to calculate the EY, right? The EY, the Y component of the electric field is nothing but the integration of dE sin theta. Again, what is the dE? The dE is what? This is the k lambda dx upon d square plus x square, and this is the sin theta. Again, the dx is equal to what? Say lambda, dx is what? Nothing. This is the dx, and the dx is this. K lambda is common. The dx value d sec square theta upon d square. The x value is d tan theta, d square tan square theta, right? And this is the d theta, d sec square theta d theta, and now the sin theta, right? So similarly, we are going to calculate, if you take the d common, denominator d square, 1 plus tan square theta, and this is the sec square theta, right? This is the d theta into sin theta. It is cancelled out. So here k lambda upon d sin theta into d theta, right? What is the sin theta? K lambda upon d minus cos theta is the limit. Again, the theta values varies from minus theta 1 to theta 2, minus theta 1 to theta 2, right? This is k lambda upon d minus cos theta 2 to minus cos minus theta 1. Is it clear? But cos minus theta is always equal to the cos theta, right? So give me 1 minute, give me 1 minute. This is the minus cos theta 2. This is the minus sign from my side, and this is the minus in term minus cos minus theta 1. So it is cos theta 1. So k lambda upon d. This is minus cos theta 2. Minus minus become plus, and it is cos theta 1. So the answer is k lambda upon d cos theta 1 minus cos theta 2. So this is the Ey. Is it clear or not? So this is the electrostatic field in the y direction, cos theta 1 minus cos theta 2, and the x direction, here it is replaced by sin theta 1 plus sin theta 2, right? Copy this first. So listen one thing, I'm writing this expression once again. If this is the linear charge density, this is the perpendicular distance, the point A is making angle theta 1, the point B is making angle theta 2. At this point, the electric field in x and y direction, the separately you can write k, and you have to remember the x component in terms of theta 1 and theta 2 is sine theta 1 plus sine theta 2, and the y component is k lambda upon d. This is cos theta 1 minus cos theta 2. And if you want to find the resultant electric field, the resultant electric field is nothing but the vector sum of Ex and Ey, that is Ax square, and the Ey square is the resultant electric field. It is clear or not? Right. I am giving you one example. For example, if this is the line charge, fine, and this angle is supposed to be the 53 degree, and this angle is supposed to be 37 degree. The perpendicular distance is d. The linear charge density is lambda coulomb per meter, and you have to find the electric field in x direction, also the electric field in y direction. The Ex is nothing but, you have to remember this formula, k lambda upon d sine, the theta 1 is what? Say 53, right? The theta 1 is 53 degree, and the theta 2 is what? Say 37 degree. Sine 37 and sine 53. Is it clear or not, you tell? So when you will simplify k lambda upon d, it is 4 upon 5 plus 3 upon 5 is equal to 7 k lambda upon 5d. Is it clear? This is the 5d. If you consider the Ey is nothing but k lambda upon d cos theta 1 minus cos theta 2, cos 53 minus cos 37, k lambda upon d, cos 53, this is 53, this is 3, 4, 5, it is 3 by 5 minus cos 37, it is equal to, wait for 1 minute, this angle is theta 1 is 37, please make it correct, and the theta 2 is 53 degree, right? Although it will be what? Say theta 1 37, the answer will be the same. This is the 53, this is 3 by 5, this is the 4 by 5. There is no difference, but there will be the difference. The theta 1 is what? 37, right? And it is 53. So the cos 37 is nothing but 4 upon 5, and this is 3 upon 5. So when you will simplify k lambda upon d into 1 upon 5, 4 minus 3, 1, 1 upon 5. So this is k lambda upon 5d. Is it clear or not, you tell? Right. Now, if you want to find the resultant electric field, so if this is the line charge, this is the point P, this is 53 degree, this is 37 degree. So this is the Ex, this is the Ey. The Ex is 7 k lambda upon 5d. It is k lambda upon 5d. The resultant electric field is root over Ex square plus Ey square is equal to plus 5 k lambda upon 5d का whole square. K lambda upon d is common. It is 49 upon 25 plus 1 upon 25. So when you will simplify 50 upon 25, this is k lambda upon d root 2 is the net electric field. Are you getting or not? Now if this is the net electric field and if you want to write this angle alpha, how to find this alpha? The tan alpha is nothing but perpendicular upon base. This is the EY upon EX. So you may write the EY value. The EY value is, it is equal to k lambda upon 5d is equal to 7 k lambda upon 5d. Right, so it is equal to 1 upon 7 tan alpha. So the alpha is equal to tan inverse 1 upon 7. Is it clear or not? So this is the magnitude of the resultant angle field and resultant electric field, and this is the angle made by the horizontal. Is it clear or not? Right, copy this. So yesterday the linear charge density, right, the finite linear charge density A and B, we have seen if this angle is theta 1 and this angle is theta 2, right. Here if you assume this is the y-axis, this is the x-axis, right, the Ex we have written k lambda d sine theta 1 plus sine theta 2. Is it clear? And this is the Ey k lambda upon d, right, it is cos theta 1 minus cos theta 2. Fine. So I'm giving one more example, right, few more examples, sorry. For example, if theta 1 and theta 2 both are equal, right, then if this is the rod and it has the linear charge density supposed to be the lambda coulomb per meter, right, it is the midpoint, right, and this distance, suppose this is the distance d, the rod of length L is over there, and this is the point P. Right, so you have to find the electrostatic field at point P as shown in figure, right. So this is the question. The length is L at separation D, perpendicular distance, and it is the midpoint. You must remember this is the perpendicular bisector, right. If this is theta, also this is theta, this is the perpendicular bisector. So how to do that? Listen one thing. In this case, I'm writing the solution this side, right, or you may copy in one figure only, right. If this is the theta, right, this is the theta 2 and this is the theta 1, right. So theta 2 and theta 1 is equal to theta. So if you consider this is the Ex and this is the Ey, so if you consider the Ey k lambda, fine, this is k lambda upon d cos theta minus cos theta, fine. So there is no y component in this direction because of this positive charge. Is it clear or not? You tell. Suppose this is the rod AB. And now what about the Ex is nothing but k lambda upon d, sine theta 1 plus sine theta 2. Here theta 1 and theta 2 both are equal. So it is equal to 2 k lambda upon d, right. It is 2 sine theta, so I am writing 2 sine theta. Is it clear or not? So only the x component electric field is present at this point, and this is 2 k lambda upon d into sine theta, but sine theta is not given. You can write the sine theta. Suppose this is the d, this is L by 2, this hypotenuse is d square plus L square by 4, right, root a square plus b square. So what will you write the sine theta over here? Sine theta is the perpendicular upon hypotenuse, d square plus L square by 4, right. If you simplify this, this is L by 2 upon 4 d square plus L square 4, right, d square plus L square by 2, because the 4 square root is 2, this cancel out. So sine theta I can write L upon root over 4d square plus L square. So this is the value of the sine theta, right? So here the electric field at point P only due to the Ex, and this is equal to 2k lambda upon d. And what is the sine theta? Sine theta is L upon root 4d square plus L square. So in this way you can write directly the electric field due to this finite length linear charge distribution with the help of the formula. No need to integrate again and again. If you use this two formulae, right, then you can write the electric field. Is it clear or not? So because of this linear charge distribution at perpendicular bisector at distance d, the electric field is in this way, right? Otherwise you have to integrate, right, by the formula, right? So this is the electric field. This is 2k lambda upon d sine theta. In this way you can remember if this is theta and this is also theta. Is it clear? Right, copy this. Infinite line charge, right? That is, the line charge is extended from minus infinity to plus infinity. Everywhere the linear charge density is uniform, lambda coulomb per meter, and you want to write the electric field at this point at distance d, perpendicular distance d. So how would you find u? Tell, right? Listen one thing. If this line charge is extended little bit, so what will happen? The theta will increase. If you further increase, the theta will increase. If the further line charges increase, the theta is again increase. So what will you tell? What if this is the theta and the line charge is increasing continuously like this, like this, like this, like this? So for the infinity line charge, what is the value of the theta? You tell me. 90 degree, right? So for this line charge like this, for the infinite line charge, the theta 1 become, this is I think theta 2 become 90 degree, right? This is the theta 2, and in the same way the theta is what? Theta 1 also become 90 degree. Are you getting or not? Although directly you can write the Ex value and the Ey value, right? So the Ex value is what? Listen, if Ey you can write k lambda d cos theta 1. This is theta 1 and cos 90 degree minus cos 90 degree. Is it clear or not? So it is what? So 0. So no Ey, only the Ex. This is symmetric like this, only the 2k, right, k lambda upon d sine 90 plus sine 90. Or in this expression also you can write down 2k upon d into sine 90. So it becomes 2k lambda upon d. Sine 90, 1 plus 1, 2k lambda upon d. So the electric field only in this direction, and which is equal to what? Say 2k lambda upon d, and you have to remember this, right? The electric field due to infinite line charge at this point, 2k lambda upon d, you have to remember, right, from minus infinite to infinite. Is it clear or not, you tell? Right, copy this. If this is the infinite, what about the semi-infinite? Semi-infinite line charge. What is the meaning of the semi-infinite line charge? The semi-infinite line charge mean it is start from here, it goes to this up to infinite. Is it clear or not? So at this point, perpendicular distance d, you have to write the electrostatic field. Is it clear or not? Right. So think about this, how to write the electric field with the help of these two formulae. Right, copy this. So let's see for this semi-infinite line charge. Semi-infinite line charge. Tell me, if the line charge is extended like this, right? if this is theta 1, this is theta 2, the Ex is this, the Ey is this. It is k lambda upon d sine theta 1 plus sine theta 2. It is added. And what about this? It is k lambda upon d. Fine. And this is cos theta 1, right, minus cos theta 2. This formula you have to remember. So if this point start from here, there is no portion in this side. So what is the value of the theta 1? You tell. The theta 1 is 0. And for this, the theta 2 is 90. Is it clear or not? So for this is the theta 2. For this, right, the point B is tending to infinity. Therefore, the theta 2 tending to 90 degree. You may write it is tending to. And what about the theta 1? Theta 1 is equal to 0 because no portion this side. Right. So therefore, in this case, you can write either you may write this is the Ex, this is the Ey. Fine. The Ex value I am writing according to this formula. This is k lambda upon d. Fine. The theta 1 is sine 0 and theta 2 is sine 90. So this is value k lambda upon d. 0 plus 1 it is. So this is the Ex value. What about the Ey value? K lambda upon d cos theta 1. The theta 1 is what? Say 0. And what about the 90? So it is 1 minus 0. 1 minus 0 it is only k lambda upon d. Is it clear or not? Fine. So this is the Ex. I am writing this side. You may write only in the same figure if you want. This is the infinity. So at this point, the electric field is x direction. It is k lambda upon d. Right. Due to all this portion, the electric field is what? The k lambda upon d. This is the Ey. You may write this is the Ex. This is the point P. Perpendicular distance lambda coulomb per meter. So what is the resultant electric field at this point? The resultant electric field is what? K lambda upon d root 2. And if you consider this angle is alpha, so what is the tan alpha? Is nothing but Ey upon Ex, and the Ey and Ex both are same, so therefore it is 1. It is tan 45 degree. So alpha is what? Say 45 degree. Is it clear or not? So in this infinite line charge, the electric field is 2k lambda upon d in this direction. Because of this semi infinite line charge, the electric field, the resultant electric field is in this direction. It is k lambda upon d root 2, and this angle is 45 degree. 45 degree. Is it clear or not, you tell? So you must remember this. K lambda upon d root 2 in this direction. This is the k lambda upon d. This is the k lambda upon d. In the Ex and Ey, both components are equal for the same infinite line charge. Right? Copy this. So let's do one more important problem. Right? The linear charge is extended like this. This is the A and this is the B. And the linear charges lambda coulomb per meter is extended from A to B. And suppose this is the perpendicular distance. Right? Here you have to find the electric field such that this angle is given as the 37 degree and this angle given as the 53 degree. You understand or not, you tell? Right? This is 37 degree. This is 53 degree. You have to find the electric field at point P, right, as shown in figure. As shown in figure. Right? This is the question. Think about this. Although we know the value, right, we are going to write the formula Ex and Ey. Directly we can use. We are not going to integrate and all this thing. Sin theta 1 plus sin theta 2, we have this formula. For the k lambda upon t, cos theta 1 minus cos theta 2, we have this formula. Now only the thing is that you have to tell me the value of the theta 1 and theta 2, right? Copy this and try. What can you think? You go the basic derivation or the basic formula, right? This is the finite line from A to B. This angle is theta 1 and this angle is to be theta 2. This is the reference angle, right? If you think about the point B from the reference line, this is the reference line 0 angle, right? The point B as present at the 53. So the theta 2 is in its correct direction. So the theta 2 can be written as the 53 degree without any problem. Is it clear? To consider the theta 1, listen one thing. If it is 37 degree and if it was 53 degree, we have done this. So this is the reference angle. So in this case, the theta 1 is, right, theta 2 is 53 degree. And theta 1, you have to measure the angle from this reference line. In this direction it is positive, in this direction it is positive. So if the line charge was like this, so theta 2 is 53 degree and theta 1 is what? Say 37 degree. Is it clear or not? But in this case, this point A is not below this reference line, rather it crosses this line. Listen one thing. If this point A decreases, right, this length decreases. So here, if this is the angle, so the angle decreases. If the point A goes this side, the angle again decreases. If the point A goes this side, the angle again decreases. At this point, the angle is, in this case, the theta 1 is 0 degree. You understand or not? But if it crosses this point and goes here, the angle theta 1 become what? Negative. Is it clear or not? Below this, it is positive. At this point, the theta 1 is 0. But if you move above this reference line, the angle become negative. So here, the A point is not below the line, below this reference line, rather it is above the reference line, right? So the A point is this angle is 37. So here the theta 1 angle is minus 37. You have to write. And you have to put in this formula, you can get the answer. So I am putting, it is k lambda upon d, right, sine theta 1, sine minus 37, right, plus sine 53. You can calculate k lambda upon d, right, it is minus sine 37, it is minus sine 37 and it is minus 3 by 5, right, plus 4 by 5. When you will calculate, right, k lambda upon d minus 3 plus 4 upon 5, so it is equal to k lambda upon 5d, k lambda upon 5d. Is it clear or not? So this is the Ex value. And what about the Ey value, you tell? The cos minus 37, right, minus cos 53 degree. Is it clear? Cos minus theta is the cos 37, right, cos minus theta is equal to cos theta. Cos 37 is what? It is 4 upon 5. And cos 53 is 3 upon 5. So it is k lambda, let me check, cos 37, it is 3, 4, 5, this is 37, it is 4 upon 5, right, it is, and cos 53, 3 upon 5. So this is again k lambda into 1 upon 5, so k lambda upon 5d, right. So wait for 1 minute, minus 37 plus, minus, yes, this is the correct answer. So this is k lambda upon 5d and k lambda upon 5d. So if you know the Ex and Ey, this is the Ex, right, after this you can write the Ey, right. So the resultant electric field is root over Ex square plus Ey square, because Ex and Ey both are same. So therefore it may be written as k lambda upon 5d whole square, and this is k lambda upon 5d whole square is equal to k lambda upon 5d root 2 is the resultant electric field, right. Copy this. Okay, now we will see the electric field due to circular arc, right, due to circular arc. Circular arc mean the circular arc is like this. Is it clear or not? You tell. Circular arc. This is the circular arc, right? First, you will consider the electric field due to semicircular arc, right? Semicircular arc mean the electric field due to this semicircular arc you have to find. The semicircular arc mean the this is the charge, right? You can consider the either the total charge on this circular arc is q, the radius of this circular arc is r. You have to find the electric field due to semicircular arc at center. You can see, right? You have to find this. Listen one thing, before doing this, you tell me if this is the complete circle and the charge is distributed over the, right, over the circumference like this. Suppose the total charge q is distributed over the circumference. Can you tell me what is the electric field at the center? The electric field at the center, can you tell? Yes, we can tell it easily, right? Tell me, if you consider the any small charge, and because of this charge the electric field is d in this direction, so in the opposite side, on the opposite direction, the opposite side, the electric field is just in the opposite direction. So this electric field is cancelled out. So for every elemental charge, the electric field is cancelled out on the other side of the elemental charge. So what is the electric field at center over here? Say 0. If the charge is distributed over the complete circle, is it clear or not? But here what you have to do, you have to find the electric field at this center. So the electric field will not be 0. Is it clear or not? So this is the thing. You can write first this in the side, and now how to find this electric field at this point, let's see. First copy this. So let's see how to solve this question or the concept. The result you have to remember ultimately. Listen, this is the reference line. You assume at angle theta, right? You assume the elemental portion, and this is the elemental charge you may assume to be the dq at angle d theta, right? This is the dq. So because of this dq, the electric field is the elemental electric field dE in this direction. In the same way, by the symmetry, right, this angle is theta, and you can assume this angle is d theta. This portion angle, the charge is what, dq, and because of dq, the elemental electric field is dE over there. Is it clear or not, you tell? Fine. This is the dE. What is the value of the dE? You tell. The radius is r. This is k dq upon r square, the elemental electric field. If this angle is theta, this is theta, this is also theta. Because of this dE component, right, because of this dE, this is the sine component. Cancel out by the sine component of this. Is it fine? So this sine component are cancel out. So what are the dE cos theta and dE cos theta? So 2 dE cos theta. 2, this is 2 dE cos theta. So the if you integrate this 2 dE cos theta, if you integrate this, you will get the electric field at this point P. Whether you write it as P or O, whatever you write, right? This is the net electric field. And what is the dE? dE is nothing but k dq upon r square into cos theta. Fine. Listen one thing. In the inside the integration, dq and cos theta, two variables are there. So you have to convert the dq in terms of the theta. How would you write? I will explain. Listen one thing. This is the total length. The charge is distributed over the length. Therefore, this is the linear charge distribution, right? Although, so what is the length? The length is pi r. In the pi r length, how much charge is distributed? The charge is distributed to be q. So in 1 meter length, what is the charge distributed? You tell. The q upon pi r. Is it clear or not? And we have to find this dq charge. This is the dq. Assume this elemental portion, the length is to be the dx. So angle is equal to arc upon radius. So what is the dx? Say r into d theta. Angle is equal to arc upon radius. Is it clear or not? This is the dx portion, dx length, elemental length. What is the total length? The total length is pi r. What is this element length? Say element length is dx. So in pi r, the charge is q. In 1 meter, q upon pi r. So in dx meter, what is the charge? You will say q upon pi r into dx. And in this dx meter, this is nothing but the dq, q upon pi r into dx, and the dx value is r d theta. Is it clear or not? I am writing this side, dE is equal to k dq upon r square. So therefore r will cancel out. Theta, this is the, sorry, this is not theta, it is q. Q upon pi d theta is the value of the dq, right? So with the help of this elementary method, the angle d, the elemental charge dq is written as in terms of theta. So I am putting here the value. This is 2k upon r square. The dq is nothing but q upon pi into d theta, right? And this is the cos theta. Now you can integrate. This is 2k q upon pi r square, and this is the cos theta d theta. Is it clear or not? Now the only to put the limit over here. From where to where the elements are elongated, elements are present. From the element start from here. This is the element. This is the element. This is the another element. So the element start from theta is equal to 0, then 30, 40, 50, 60 degree up to 90 degree. Is it clear or not? So 0 to 90 degree, right? 0 to 90 degree you have to integrate. So this is 2kq upon pi r square, and the cos theta integration is sine theta from 0 to 90 degree. If you put the limit, then you can get the answer. The electric field at the center is 2kq upon pi r square, right? First put 90 degree, sine 90 minus sine 0. Fine, sine 90 is 1, so 2kq upon pi r square is the correct answer. Is it clear or not? Right. Copy this, then I will give you the short way to remember this formula. First copy this. Listen one thing. In other way, it looks little tough to remember, but if you write this expression, the net electric field, right? This is the net electric field in terms of lambda. What is the total length? Say pi r. What is the total charge? If you write the linear charge density lambda, lambda is nothing but total charge divided by total length. So q upon pi r, the charge distributed per meter. This is the coulomb per meter. This quantity is nothing but the linear charge density. So if you consider the linear charge density, lambda is equal to q upon pi r. Is it clear or not? So you may write like this, 2 upon r and q upon pi r. You can write like this, and this is nothing but equal to lambda. So you may write it as 2k upon r into lambda. That is, the electric field at the center is nothing but 2k lambda upon r. So it is easy to remember, because due to the infinite line charge also the electrostatic field was the same, right? So it is better, right? After this, first write this, and after this you can write in this way. If this is the linear charge density, the lambda of this semicircular arc, lambda coulomb per meter. So here symmetrically the electric field at the center will be vertically down. Its direction is vertical down, and it is 2k lambda upon r. It is easy to remember. If lambda is given, then 2k lambda upon r. If q is given, right, then you can replace the lambda is equal to q upon pi r, right? And if you put the 2k upon r, the value of the lambda, q upon pi r, so you can write 2k q upon pi r square. So the electric field in terms of q is 2k q upon pi r square, as we have found. In terms of the linear charge density is 2k lambda upon r. It is easy to remember, right? Directly we use this as a formula. Okay, copy this. So this is the electric field we have found due to the semicircular arc. Right, now you may write the electric field due to circular arc. circular arc. What is the circular arc? Here it is a semicircle. I'm taking a small part of the circle like this, right? This is the circular arc, right? So the charge is present over here. Is it clear or not, you tell? Right? And it is the angle alpha made on the center. So definitely the electric field will be in this direction, but what will be the magnitude, you tell? Right? If you assume the total charge is q, total charge is distributed q, the radius r, how would you find the electric field? In the same way, at angle theta d theta element you will consider, at angle theta d theta on both sides you will consider, the sine component will cancel out, the net electric field will be equal to 2 dE cos theta. So this electric field, nothing but you have to write 2 dE cos theta, and everything will be same except the limit, right? So I'm writing from here, when you will simplify this, you will get 2kq upon pi r square. Is it clear? And integration of the cos theta d theta. Here the integration of cos theta d theta from theta is equal to 0 to 90 degree, but here the integration will be varies from 0 to alpha. 0 to alpha. You must understand this. Is it clear or not? Everything will be the same, only the limit from 0 to alpha instead of 0 to 90 degree you have to write. Now you can write 2kq upon pi r square, and this is the sine theta from 0 to alpha, right? First put the sine alpha, then put the sine 0. Sine 0 is 0. So the answer is 2kq upon pi r square sine alpha. Is it clear or not? So although it is the electric field in terms of q, but if you want to write the in terms of lambda coulomb per meter linear charge density, then you may write 2k sine alpha upon r into q upon pi r. Wait for 1 minute, but it is not pi r over here, right? Listen one thing, how to write the lambda. What is this length? Please tell. What is this length? This length L, right? Look carefully. This is the length L. So angle is equal to, total angle is what? Angle is equal to arc upon radius. So L is equal to what? 2 alpha into r. Is it clear or not, you tell? So what will be the lambda? You will write lambda is nothing but the total charge is q, right? For 1 minute, the charge dq is equal to, no, there will be the mistake. Look, there will be the mistake. I am doing this once again. Although you have to take the electric field is nothing but 2 dE cos theta as it is, right? The electric field you will write k dq upon r square into cos theta, right? And this is 2k upon r square cos theta into dq, you have, right? And now dq you will write, how to write the dq? The small dq is nothing but q upon, how would you write the small dq? Please tell. Here this is the dq and this angle is d theta, right? This distance is assumed to be the dx. So the thing is that dq have to write. This is the elemental portion, the dx, the dq. How would you write the dq? dq is nothing but equal to lambda into dx, right? Lambda is the linear charge density, suppose lambda into dx. And what is the lambda? Lambda is nothing but, if you assume in terms of the lambda, you can, I am writing in terms of lambda first, right? And this is the lambda. And what is the angle? The angle is equal to arc upon radius. So dx value is nothing but r into d theta. So this is the value of the dq. So I'm writing this 2k upon r square into cos theta, and the dq value is lambda r into d theta. So you may write 2k lambda upon r, and this is nothing but cos theta from d theta. Is it clear or not? Now the angle varies from 0 to alpha. The integration is r, this is sine alpha, sine theta from 0 to alpha. When you will put 2k lambda upon r, sine alpha minus sine 0. So the electric field will be 2k lambda upon r into sine alpha. Is it clear or not? In terms of lambda, this is the thing, right? So this is the complete derivation, no problem at all, right? 2k lambda upon r into sine alpha is the electric field. If alpha become 90 degree, here as it is shown in this figure, right? If alpha is 90 degree, right? After this you can write alpha is 90 degree, mean it become what? The semicircular arc, right? So what is the electric field at this point? Sine 90, 2k alpha, 2k lambda upon r sine alpha, sine 90 degree, right? It is equal to 2k lambda, which is the correct relation. So it is better to remember in terms of lambda, 2k lambda upon r into sine alpha, right? The lambda value you can write later in terms of the q also, right? First copy this, then I will explain, right? Copy this. If you want to write this expression in terms of q, what will you write? The lambda is replaced by q only. Can you tell me what is the value of the q in terms of lambda? Listen one thing here, in the side here I am going to write, after this the lambda is nothing but total charge. Suppose the total charge is q and total length is L, right? And what is the total length, you tell? The angle 2 alpha, angle is nothing but arc upon radius. So what is the L? So L is equal to r into 2 alpha. 2 alpha is the angle. So what is the q? Q is equal to lambda into L. And what is the q is equal to lambda into L, and what is the lambda is equal to q by L, and their length is r into 2 alpha. So this is the value of the lambda. Is it clear or not? So you can put the value of the lambda here. Fine. So I am putting the value of the lambda. If you put the value of the lambda, so the electric field you can write 2k upon r, 2k upon r, and this is the lambda. So what is the value of the lambda? Say q upon r into 2 alpha, right, into sine alpha. Is it clear or not? So it may be written as what? Kq upon r square sine alpha upon alpha, right? This is also the very good expression in terms of q. Kq upon r square sine alpha upon alpha is the electric field due to the charge q. Suppose if you have given this is the circular arc, the total charge is what? Assumed to be the q. The angle is what? This is alpha, this is alpha. What is the electric field over here? K q upon r square and sine alpha upon alpha. Is it clear or not, you tell? This is also used sometime. Kq upon r square, q is the charge, r is the radius. At the center, kq upon r square is very simple to remember, and sine alpha upon alpha. What is alpha? You have to remember this is the angle alpha. All right, copy this. Right, first copy this, then in terms of q you may write, but it is better to remember in terms of lambda, right? You can copy now.